What are malware packers? In this video, we're going to take a look, do a deep dive, and see what malware packers do. They not only obfuscate code, but make it much harder for a malware analyst to do their job. This video, we're going to dive deep, take a packed malware sample, and I'll show you how to run it through a debugger, and then find the unobfuscated code so that you can go forth and reverse engineer. See you on the other side.
Welcome back, everyone. We are going to go ahead and unpack another malware sample with our x64 debugger this time. Remember, a couple videos ago we used the x32 debugger. This one we are actually going to go ahead and go with a x64. I already have this syswow downloaded. This is a packed malware sample. So what we're going to do is drop it in there. And right now we have just our breakpoint set as our entry breakpoint. So one of the things that this particular malware sample is going to be using is the VirtualAlloc and VirtualProtect. And so if we take a look now, we've loaded those. Use the semicolon to break it into two separate, but we do see here that we have a syswow.exe, and loaded up we have a VirtualAlloc and VirtualProtect. So what we're going to be doing here in this instance, or what we're going to be seeing, is when VirtualAlloc is called, it's going to be allocating that memory, and it's going to be for shellcode. It's going to set up that memory region, and then when it calls VirtualProtect, it's going to convert the properties of it to executable. So let's just jump right in here, and what we want to go ahead and take a look at, you could hit run, and this is going to take us right to the first entry point. You can hit run or F9. We're going to just hit run there, and that drops us into the VirtualAlloc. Something that I want to show here is that with VirtualAlloc R9, we have 4, which is basically the parameter that's passed to VirtualAlloc, and that has to do with the property protections that it's calling. If we then go ahead and go in, and we're going to execute till return. This is similar to what we did in our previous video, because it takes us into that next return statement after VirtualAlloc, so that we get the memory address that it allocated. And RAX right here is holding this memory address that we're going to want to follow. So we're going to go ahead and hit follow and dump, and we have our 1B set up here. Next thing that we're going to want to do is to step over. That allows us to jump in or step into the function, because I want to show here that there's a loop. So if we're going to, for this one, hit F8, so we can actually look and see what's happening at this dump address. So let's go ahead and just do this a couple times, because what this is actually doing is conducting a de-obfuscation technique. So it drops in and it's going to continue going over and de-obfuscating this malicious shellcode. So as you see, as we continually hit F8, it'll go back and it's going to be populating what's going on in this memory region. I'm going to speed this up a little bit. Click on to right after the loop ends, which is this move RCX RBX. We're going to click run until selection. And as you can see here, this has populated and this malicious shellcode has been populated with everything de-obfuscated. And what you'll see here is when I net, you're going to also see this user agent, text, Trident 5.0. Next thing we're going to see SSH and what appears to be an IP address. So this appears to be an obfuscated first loader that is going to go out and call back to this specific address, which interesting of it in itself, but we're not quite done yet. And what we're going to want to do is go ahead and we're going to hit this run button and we're going to get to VirtualProtect. Things of interest here, as I talked about earlier, if VirtualProtect, it's going to change the permissions of that memory region. So it's allocated it, put the malicious shellcode in there, but it hasn't been set as executable. This is what this VirtualProtect is doing. And if we see here, the RCX register it's being passed is the address for our shellcode. R8 is also one of the ways to pass a parameter to VirtualProtect, and we see that it's 20, which is the actual executable or the code to make that region executable. So final thing here that we want to do is to download this shellcode. We want to be able to do that, and so what I did is right-clicked on that first byte there, and we're going to follow in memory map. This brings us to the highlighted spot. We don't want to change it. I'm going to then go ahead and dump memory to file. I'll put it on my desktop here, and I've done it before just a little bit ago, but let's just click on that and we'll hit save. And yes, I do want to replace it. We're going to then be able to open this up in Binary Ninja, and I'll show you the next steps of being able to go ahead and analyze this. So again, I saved it on the desktop, this syswow, and with the load options here, you're going to want to select the correct platform, and we know that it's Windows 64, so we select that. We're going to hit open, and I will increase the size here, and we'll start seeing some of these strings that were similar to what the malicious code or the shell code once we've done it. But now we actually have a linear view of what this malicious shell code. So now you've had the opportunities, we can take a look, and here's the IP address, Here's the user agent, the win inet, a little bit of everything else that we see here. Again, we can go and take a look at the different types of the symbols and so forth. And so I encourage you to go ahead and take a look at everything else that's being done. And I just want to go back to the linear view here and show that, yeah, take a look. So go ahead and drop a comment in what you think is going on. What do you think this malicious shellcode is doing? Maybe if you want to reverse engineer it. But if you found this helpful, I'd appreciate a hit on that like and subscribe button. Thank you, and we'll see you in the next video.